It is given that three liquids A, B, and C of masses 400, 600, and 800 gram are at 30, 40, and 50 respectively. When A and B are mixed, the resultant temperature is 36, and when B and C are mixed, the resultant temperature is 44. Then the ratio of their specific heats are. So we are considering three different cases over here. So in the first situation, we are assuming that there is some amount of liquid in a container. So we are just considering these three liquids, three different liquids, take it as A, B, and C. So three liquids A, B, and C of masses. This one is of 400 gram, and second one is of 600 gram, and third one is of 800 gram. Are at 30 degrees Celsius. This is at 30 degree, and this is at 40, and this is at 50. When A and B are mixed, so we don't know what about their specific heat capacity, take it as SA, and this we can take it as SB. So when A and B are mixed, the resultant temperature is 36. So we are getting the resultant temperature as nothing but 36 when we are mixing these two. So we are going to get the resultant temperature as nothing but 36. So first let us calculate on this particular part. So when we are mixing A and B, so there will be a transfer of heat energy from this B to A. So we'll use the principle of calorimetry, that is heat gain by A is equal to heat loss by B. So we can write this Q is equal to ms delta T. So we can write this ms delta T of heat gain should be equal to this ms delta T of heat loss. So m over here it is nothing but 400, specific heat capacity we don't know, let's say that is equal to SA, and change in temperature, that we know that it is initially it was 30, now it is 36, so change in temperature is 6, that is equal to, we can write now the mass becomes equal to 600, specific heat capacity we don't know, we can write it as nothing but SB, and this difference in temperature, initially it was 40, now it is 36, so there is a difference in temperature of 4. So we can just find out what about the relation between SA and SB. We can cancel 100 over here and 100 over here, 4 over here and 4 over here, and 6 over here and 6 over here. So we'll get that is SA is equal to SB, or basically SA by SB is equal to 1:1. So their ratio is same. Now we can identify what about the value for this C over here. Now for that purpose, the second part we can just observe, when A and B are mixed, the temperature is 36, and when B and C are mixed, when we are mixing these two, the resultant temperature is going to be equal to 44. Now we can observe this part. So according to this, again we can write there will be a flow of heat energy from C to B. So here you can write heat which is gained by B is equal to heat which is lost by C. So again we are writing the same thing, ms delta T of heat gain should be equal to ms delta T of heat loss. So B, the mass of B is given as something but 600, its specific heat capacity we don't know, take it as SB, and change in temperature, initially it was 40, now it is 44, so we can write should be equal to 4, and take it as the specific capacity in material C is take it as SC, and right side we can write it as mass is 800, specific capacity we don't know, we just assume that is SC, and delta T we can take it as from 44 to 50 we can take it as 6. So now we can cancel this 100 and this 100 and the 6 over here and the 6 over here, and we can just observe this 4 and this 8, then it's going to be 2. So we can write the specific capacity of B is nothing but 2 times the specific capacity of C, or you can write the specific capacity of C is nothing but specific capacity of B divided by 2. So we got these two informations. Now RM is to find out what about the value of SA is to SB is to SC. So you can write SA, I'm just writing it as SA only, is 2, and the value of SB is nothing but SA only, because from here we already derived that. So we can write SB is also equal to SA, and is 2. The value of SC, which we can take it as nothing but SB divided by 2, and the value of SB is nothing but SA, so we can write this as specific capacity of A is 2, specific capacity of A is 2, specific capacity of A divided by 2. So we can take this s as common and we can cancel it. So this will be like in the ratio 1 is to 1 is to 1 by 2, or if you are multiplying the whole equation by 2, so we'll get there's nothing but 2 is to 2 is to 1. So we are just multiplying this equation, 1 is to 1 is to 1 by 2 into 2. So we'll get it in this form, that is 2 is to 2 is to